So this question says, acetylene is a raw material used in the production of a number of organic substances. Acetylene is also a combustible material. And question 1 asks you to write out a balanced equation for the complete combustion of C2H2. So with our combustion equation, so we're taking our C2H2, mixing it with oxygen, and it's producing carbon dioxide and water, which are always the products for a combustion equation. So we have 2 carbons here, and then we have to balance it by adding 2 carbons onto this side here. And then we have 2 hydrogens, and we already have 2 hydrogens here. And we have on this side, we've got 4 oxygens plus 1 more oxygen here. And then we only have 2 oxygens. So the oxygen number on this side is 5, whereas the oxygen number on this side is only 2. So if we were to times that by 2.5, then we would have the correct number of oxygens. We would have the number of oxygens being 5. So we are allowed to multiply by 2.5 if we wish, but we have to adjust. We have to adjust that entire equation by then getting rid of the half and timesing it by 2, so that we get 2H2 C2H2 plus 5 4 2H2O. That way, now the reaction is completed. Okay, so and also all the numbers are whole. So question 2. Question 2 says, explain how the reaction in 1 would differ in low oxygen concentrations. So if you didn't have enough oxygen, then there would be an incomplete combustion equation. So if oxygen was low in concentration, this would mean that an incomplete combustion equation occurs. Okay, and what that in turn means is that you have a lot more carbon monoxide produced. So this would produce more carbon monoxide. That's carbon monoxide. Okay, there would also be a bit of carbon dioxide and a little bit of water produced as well, but not in the same proportions as here, for example, because that's when you have a complete reaction. Okay, so question 3. A student measured that there was 30.5 grams of carbon dioxide produced after the complete combustion of C2H2. Find how much mass of acetylene was needed to produce this mass of carbon dioxide. So we know how much carbon dioxide was formed. So the mass of carbon dioxide is equal to 30.5 grams. Okay, and then we have to find the mass of acetylene needed to create that particular mass of carbon dioxide. So we're starting from the products here. The molar mass of carbon dioxide is 44 gram per mole. And we're still going to be using, I'll just rewrite our formula here. So we have this. And so we will be finding from the mole of carbon dioxide, we need to find the mole of acetylene. So remember that the ratio is always what you want over what you don't want. So 2/4, and we multiply. So the mole of carbon dioxide is 30.5 divided by 44, which is equal to, if I just calculate that now, divided by 44, 0.69318 mole. Now you can see that to find the mole of C2H2, you need to use stoichiometry. You are starting off with using the mole of carbon dioxide, so you write mole of carbon dioxide, but then you know that the ratio is 2/4. Okay, so we have to go 2/4 times by the mole of carbon dioxide, and the mole of carbon dioxide is 0. This. Okay, so we just have to halve that. Alright, so we've got 0.346590. And the question asked you to find the mass of the substance. So to find the mass, C2H2, so we take the mole of C2H2 and we just times it by the molar mass of C2H2. Okay, so that's 0.34659 times by the molar mass, which is 24 plus 2. So 24 plus 2 is 26. And then we just multiply the 2 out. So we end up getting a mass of 9.01136 grams. And then we check how many decimal places we need this to, and we can see that we only have 3 significant figures for the mass of carbon dioxide. So we need to express this to 3 significant figures. Cuts off there, and that's just going to be 9.01 grams. Okay, so that's question 3 answered. Okay, let's have a look at the next question. So question 4, if 20 grams of acetylene was found to produce 50 grams of carbon dioxide, find the percentage efficiency of this reaction. Okay, so I'm just going to go down to the bottom there, write up my question. So it's question 4. So just double checking. CH2 plus 5 oxygens. Okay. C2H 5 oxygens gives us 4 carbon dioxides plus 2 waters. Okay, so we know how much of this we have. We know that we have 20 grams of this, and we know that somehow the reaction generated 50 grams of this. And now we don't know the percentage efficiency, so we don't know whether all of the acetylcholine, all of this C2H2 got reacted, or if only a proportion of it has. So what's a good thing to do is to, if you know the mass of this substance, working out the molar mass. So we already determined that the molar mass is 26 gram per mole. We also have to figure out the mole of C2H2, which is 20 divided by 26, which gives us this value. Okay, and using this information, we can then use stoichiometry to find what the theoretical maximum would be of carbon dioxide. So to do that, we need to think about what the ratio will be. So the ratio is 4/2. So we would have to times by 2. So that way we get the mole of CO2. Take 0.769230 times by 2. So times by 2, you get 1 point. So that, and then we can work out the mass of carbon dioxide. So this is the maximum. This would mean that 100% of it gets converted. So times by 44, which is the molar mass of carbon dioxide. And if that were the case, if the maximum occurred, you would get 67.692307 grams. And so to work out the percentage efficiency of this entire reaction, you know that you got the mass of carbon dioxide, the actual. Take the actual mass, and you divide it by the mass of carbon dioxide at the maximum level, and then times it by 100. Okay, so the percentage in this situation would be the mass of CO2, the actual mass of 50 grams, divided by the maximum, so 67.692307, and times it by 100. So that way, 50 divided by, I'm just going to calculate it now. It is 73.8636%, and then we have to just cut it off at still three significant figures, because it's always the lowest number of significant figures. So we'll just cut it there, and that would give us 73. That 8 will go up to a 9%. So that's the percentage efficiency of the reaction. So this reaction is only 73.9% efficient.